Assalamu alaikum wa rahmatullahi wa barakatuh. I'm once again back with you all for your chemistry online class. In the last lecture I started with lesson number 9, that is carbon and its compounds. Let's quickly revise. So by now we have understood that carbon, the symbol is C, capital C, and it has an atomic number 6 and mass number 12. Electronic configuration of carbon is 2 and 4, that is why it possesses a valency of 4. Is it clear? Now we all know by now that carbon is one of the most widely distributed elements on the earth, because all the living things, whether be it plants, animals, they contain carbon, and all the things that we are using, whether it is in the form of food or fuels or various drugs and dyes, are all made of carbon. And carbon is found in the earth's crust. It is present in both combined form and in free states. In free state, carbon occurs as coal, diamond and graphite, and in combined state it occurs as carbon dioxide, petroleum, natural gas, then food nutrients and carbonates, and in the form of fibers like rayon, cotton and silk. And the compounds of carbon, hydrogen and the derivatives are called as organic compounds, and the branch of chemistry that deals with the study of these compounds is called organic chemistry. So they are these organic compounds are used in our day-to-day life as food nutrients, like in the form of proteins, fats and carbohydrate, in the form of fibers like wool, silk, cotton, etc., in the form of fuels like petrol, kerosene, diesel. Then it is used in the form of detergents and soap, and also used for making paper, perfumes and disinfectants. So the branch of chemistry that deals with the study of compounds other than organic compounds is called as inorganic chemistry. So in this we have all of the compounds that we have studied till now, that is carbon monoxide, carbon dioxide, carbonates, bicarbonates, etc. So you can see these hydrocarbons include methane, butane, etc., and these are the formulas, that is CH4 of methane, then methane, and then ethane is C4H10, then benzene is C6H6, and so on. Similarly, for alcohols we have methyl alcohol CH3OH, ethyl alcohol C2H5OH. Let's proceed on further today. So what is allotropy? Now this is the phenomena of existence of an element in two or more different forms, and these different forms have same chemical but different physical properties. So an element existing in two or more physical forms. The property of some chemical elements to exist in two or more different forms, this is called as allotropy, and such forms of an element are called as allotropes. So two or more than two forms of an element having different physical properties but same chemical properties. Remember, they have same chemical properties but different physical properties. They are known as allotropes of an element, and such condition of element is known as allotropy. And what is the reason for this? The reason is that because of their different structures. So difference in physical properties of different allotropes of an element is due to their different structures. So some elements that show allotropy are carbon, sulfur, oxygen, phosphorus and carbon. I have told you carbon, sulfur, phosphorus and oxygen, they are the elements which possess or which exhibit allotropy. So we will discuss in this chapter the allotropes of carbon. So the allotropes of carbon are of two types, that is the crystalline and non-crystalline or amorphous form of allotropes. So you can see in this chart the carbon has two forms, that is crystalline and amorphous or non-crystalline form. So in crystalline diamond and graphite, and one more, that is fullerene, which we will discuss later on in this chapter only. Amorphous includes coal, charcoal, lamp black, and in coal we have coke and gas carbon. So these are the two different forms of, or two different types of carbon, allotropes, which carbon shows. So what are the crystalline forms of allotropes? So when carbon atoms are arranged in a definite geometrical pattern with plane surface, it is called a crystalline form. Or in other words, you can say that this form in which the allotrope or that particular element shows a definite geometrical form. So graphite and diamond and fullerene are the different crystalline forms of carbon. And when the carbon atoms are not arranged in any geometrical pattern, but they are arranged in an unsystematic pattern, they are known as non-crystalline or amorphous form. In this we include the coke, charcoal and coal. They are all amorphous form of carbon. Is that clear? So the physical properties of all the forms of carbon are different. Graphite, fullerene, diamond, coke, charcoal, all of them possess different physical properties, although the chemical properties are the same. Now, however, when they are heated in the presence of oxygen, they give carbon dioxide and heat. So any form of these allotropes, that means all of them will have a symbol C, and they are carbon, and when they are heated in the presence of oxygen, they give carbon dioxide and heat is evolved. Is that clear? Whether you are heating graphite, you are heating coal, whether you are heating coke, all of them heated in the presence of oxygen give out carbon dioxide and heat is evolved. Is it clear? Now allotropes of phosphorus are yellow phosphorus, red phosphorus and black phosphorus, that is black. Apart from these, there are white, scarlet, violet phosphorus also. And when we compare them to the allotropes of sulfur and oxygen, so these are the allotropes of oxygen, molecular oxygen, that is O2, dioxygen and O3. Apart from them, now we have O4 and O8 also. Then for allotropes of sulfur, we have rhombic sulfur, monoclinic sulfur, plastic sulfur and colloidal sulfur. So they are rhombic sulfur, monoclinic sulfur, plastic and colloidal sulfur. So these are different allotropes of sulfur. We can see that carbon, sulfur, phosphorus and oxygen all show the, or all exhibit allotropy. Now discussing the different forms of crystalline carbon, that is diamond first. That is, it is the purest form of carbon, and in India diamonds are found at Panna in Madhya Pradesh. You can see this, they are here, that is Panna in Madhya Pradesh. These are the very famous Panna mines. And then Vajra Karur in Andhra Pradesh. Is that clear? This is the place, Vajra Karur, where diamond is mined. So the two most important places where diamonds are mined are Panna and Vajra Karur. And this world map shows the places where where diamond is mined throughout the world. That is, it is found in South Africa, then in Russia. Here you can see that it is found in South Africa, then in Russia, Australia, USA. Here USA, although it is not given over here, it is given as Canada, but it is found in USA, Namibia and India. Is that clear? So all these places are famous for their diamond mines. What are natural diamonds? Now the word itself, that is through nature. So natural diamonds are formed by the action of high temperature and pressure on carbon present at a depth of about 150 kilometers. so deep, 150 to 200 kilometers deep inside the earth, and sometimes volcanic eruptions bring these diamonds to the surface of the earth. And some famous natural diamonds are Kohinoor, Pitt diamond and Cullinan. So when this all the carbon that is present under the earth is exposed to high temperature and pressure, they change into diamond, and this steps, the temperatures are very high, between 900 and 1300 degrees, with pressure ranging from 45 to 60 kilobars, extreme pressures. Is that clear? And we also know that the weight and quality of diamond are measured in carats. You must have heard your mothers speaking about jewelry that is of 22 carats or 20 carats. That is the unit for measuring the purity of jewelry is, or gold or diamond is in terms of carats. So you can see different carat diamonds over here, 2.5, 2 carats, 1.5 carats. So the weight and quality of diamond are measured in carats. So 1 carat is equal to 200 milligrams, or approximately the same width as a pencil eraser, the eraser that used for rubbing the pencil mark, and the same weight as most aspirin tablets. So that is equal to 200 milligram. Is that clear? 1 carat is equal to 200 milligram. So the weight and quality of diamond are measured in carats. So pure diamond is a colorless, you can see all of them are colorless, lustrous and crystalline solid. It has negligible impurities and are very expensive. Whereas some diamonds have distinct colors such as red, pink, blue. You can see the different colors of diamonds in this picture, and these colors are due to the presence of impurities such as traces of metal oxide and salts. So these colored diamonds are called gems. So they are also known as gems, 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 not the gems that you eat, but these are the colored diamonds. And black diamonds contain copper oxide as impurity. Although they are not used as gem, they have important industrial applications. This is a black diamond, and you can see that this contains copper as impurities, and it is not used as in jewelry making, but they have important industrial application. Then this is about natural diamonds, that when natural diamonds are formed by the action of high temperature and pressure on carbon present at the depth of about 150 kilometers inside the earth, whereas artificial diamonds are made artificially from graphite. So where we are using this graphite in our daily life, we are using it as pencil leads, and the diamond are made artificially from this graphite. When graphite is subjected to high temperature, this is graphite, and when it is subjected to high temperature of about 3000 degrees Celsius, and in the presence of air, to form synthetic diamonds or artificial diamonds. So when we subject graphite to a very high temperature of about 3000 degrees Celsius in the presence of air, then synthetic diamonds are formed, and these diamonds are small in size, and they are used in industries as cutting and grinding tools. So in 1886, Moissan was the first person to prepare artificial diamond, and he prepared it by heating a mixture of sugar, charcoal and iron in an electric furnace. Now talking about the structure of diamond. Now diamond has a giant molecular structure. So it has 4 valence electrons. We have already discussed that it has an atomic number of 6. So its electronic configuration is 2 and 4. So it has 4 valence electrons, or in the words you can say it has a valency of 4. Now each atom or each carbon atom in the diamond crystal is linked to 4 other neighboring carbon atoms. You can see over here each carbon atom is linked to 4 carbon atoms. You can see in this figure also they are linked to 4 carbon atoms. and these carbon atoms are linked by strong bonds. Is that clear? These carbon atoms are linked by strong bonds and form a rigid three-dimensional tetrahedral structure. Now this structure is rigid. First of all, you cannot easily move its carbons. They are rigid, fixed at the places. They cannot be easily moved and form a three-dimensional tetrahedral structure. So tetrahedral structure, you can see this is known as a tetrahedron, and this is the tetrahedral structure which is visible over here. Now the four surrounding carbon atoms are at the four vertices of a regular tetrahedron. They are at the vertex here, vertex end points over here. Must have studied about the term vertex. Is that clear? That is, they are at the four corners of a regular tetrahedron. So this unit, this is the basic unit of a diamond crystal, which repeats itself and extends in all the direction. It extends, you can see here this carbon atom is linked to the four other carbon atoms, here also and here also. So this structure repeats itself and extends in all the direction. And what is the result of this? The result is the formation of three-dimensional rigid octahedral shape. Is that clear? It results in the formation of three-dimensional octahedral shape. So this is the tetrahedral site lies in the center of a 4-atom cluster within the crystal. So as I had shown you that one carbon is linked to 4 carbons like this. Similarly, this repeats itself like this. So when atoms of the same size are packed together as closely as possible, there are 2 tetrahedral sites per atom. An octahedral site is a space at the center of a cluster of 6 atoms that form an octahedron. Is it clear? We all know that diamond is the hardest known natural substance. And why is it hard? It is hard due to the presence of three-dimensional rigid structure, which I have shown you just now, and strong bonds between the carbon atoms. So black diamonds being the hardest, containing copper as the impurity. So diamond is the hardest known substance, natural substance, just because of the presence of three-dimensional rigid structure and strong bonds. And it is transparent and colorless just because of presence of certain impurities. Colored diamonds are also found. It has a high density and of 3.5 gram per cc or centimeter cube. This is the density of diamond, and this is due to the rigid structure of diamond. That is why it has a high density. It is a poor conductor of electrons just because there are, in the structure itself we have seen, there are no free electrons left and all the electrons are involved in the bond formation. So it is a poor conductor of electricity, and the refractive index of diamond is very high, that is 2.5. This is the refractive index of diamond, and when light enters the crystal of diamond, it undergoes multiple reflection, due to which it sparkles. So here you can see the refractive index of diamond is very high, that is the critical angle for diamond air interface. Critical angle you must have studied in physics. It's 24.4, and when light from an external source enters in a well cut diamond, it suffers multiple total internal reflection. You can see this reflection, and when at any surface the angle of incidence is less than 24.4 degree, only then it may refract out. Thus the light entering the diamond from all direction emerges out from some directions, and therefore looking for these direction the diamond appears to be sparkling. Apart from this, it has a very high melting point, around about 3550 degrees Celsius. So a lot of heat energy is required to break the strong bonds between the carbon atoms, and when it is heated at such a high temperature for a long period, that is prolonged heating, it changes diamond into graphite, and it is generally insoluble in all solvent just because of such a rigid structure. Is it clear? Now, what are the various uses of diamond? Diamond is used for making jewelry because of the extraordinary brilliant shine. You can see diamonds are brilliant and very expensive just because of their rigid structure, strength, and of course above all, that is the brilliant shine. Then diamonds are also used in sharp edge cutters for cutting glass, and 9.5 you can see in your books also, figure 9.5b, and this is used as in rock drilling equipment for drilling holes in the earth's hard rocky layers. It is so hard that it can drill hole or make holes in the earth's crust, on the surface. For cutting the rocks also, this diamond is used. Then it is used in surgery also, that is sharp edge diamonds are used by eye surgeon as a surgical tool to remove cataract from eyes. This is the picture of eye surgery. You can see here the diamond tool is used to remove cataract from eyes. Is that clear? Then it is also used as protective window, that is diamonds prevent the entry of harmful radiation. Thus they are used for making protective windows of space satellites. Is that clear? They are used for making protective windows of space satellites. So diamond is also used for making protective windows of space satellites. Is that clear? This is a spacecraft, and protective windows of such spacecrafts, we use diamond for those. Now this is the picture of diamond thermometer. Diamonds are highly sensitive to heat rays, so they are used for making highly accurate thermometers. So this is the example of the diamond thermometer. This is all for today. Please revise it. Allah Hafiz.